Hello there. Welcome to section 3 of Unit 2. And in this section, we'll be looking at fluids and pressure in fluids. Let's look at the objective of this section. The first objective is for us to be able to explain what a fluid is, describe factors that determine the behavior of fluids, and also determine the pressure in fluids at depth H. States of matter. Matter exists in one of these three forms, that's solid, liquid, or a gas. The three states of matter substance can be distinguished by the behavior when placed in a container. In the solid, the shape of the substance does not change, but in the liquid, it behaves quite differently when placed in the container. If the shape of the container changes, then the shape of the liquid also changes, but the volume also remains the same. Thus, it's very constant. Unlike the gas too, the gas state of a material also depends on the size of its container. However, a gas is different from a liquid in that it does not have a well-defined upper surface. In the gaseous state, the molecules are almost free from one another. They wander about the container that experience almost no force due to their molecules, exception collision. Liquid and gases are known collectively as fluids. Density of matter. We define the mass of a density as the mass per unit volume. And the mathematical expression is written as density equals m over v, where m is our mass and v is our volume. The unit of mass is kilogram and the unit of the volume is meter cube. Specific gravity. The specific gravity of a substance is its density divided by the density of a standard reference material, usually chosen to be water, at -40 degrees Celsius. So the formula or the mathematical expression of specific gravity is written as density of a substance divided by the density of water at 40 degrees Celsius. Pressure. We always express pressure as force over area. Pressure exerted by a fluid is defined as the magnitude force of a force acting perpendicular to the surface depending on the area over which the force acts. Mathematically, pressure is given as force over area, where we know that the unit of force is newtons and the unit of area is meter squared. We can either write it Newton per meter squared or Pascal. Now, let's look at the evaluation of pressure with depth. We know from our density formula that density equals mass over volume. Let's make mass the subject, and when you do that, you get mass equals density over volume. And in case we are to exponentiate the volume, we can exponentiate it too, so that we have area times height, so that mass right now becomes density times area times height. Multiplying through G, that's acceleration due to gravity, we are going to get mg equals density times area times height times G. That's the acceleration due to gravity. Do you remember the formula for pressure in relation to area and force? We know that pressure equals F over A. When we make F the subject from that expression, we are going to get F equals P A. In case there's a change rate of pressure, meaning we are going to get a final pressure and an initial pressure, so that we get PA minus P dot naught A as expressed here. Also, we know that force is equal to MA, which we can represent it by mg. Acceleration right now is acceleration due to gravity. When we move this expression into this side of the equation, we are going to get this whole term here written here. And right now we know that our mg here is the density times area times height times acceleration due to gravity. Hence, we will get this whole expression, which will be equated to 0. Now, we want to make pressure the subject. We have to make A out here so that P and minus P naught will stand alone. So that at the end, A here will be cancelled out throughout, and you will get P minus P naught equals density times acceleration due to gravity times height. Pascal's law. Since the pressure in a fluid depends on the depth and on the atmospheric pressure, any increase in pressure must be transmitted to every point in the fluid. And this concept is explained well with the Pascal's law. So Pascal's law states that a change in the pressure applied to a fluid is transmitted undiminished to every point in the fluid and to the walls of the container. The device that we can use to measure pressure is called a manometer, and we can calculate pressure as P minus our P naught plus rho GH, where our rho is the density, G is the acceleration due to gravity, and H is the height. We can also bring the P on one side so that we get P minus P naught, and it's called what? The gauge pressure. So the gauge pressure can be equal to what? Rho GH. Have you ever experienced that when you try and push something in water, there's also a particular force that tries to push it up? And here Archimedes explains it, and he states that when a body is immersed in a fluid, the fluid exerts a net upward force on that body, which is equal to the magnitude of the weight of the displaced fluid. And here, the two forces here are going to be pressure down and pressure up. And from our already derived formula, we know that what? The change in pressure is equal to what? Rho GH, where rho is the density, G is the acceleration due to gravity, and H is the height of the object. And it can be negated or it can be positive, depending on the convention.